Hello, hello. Can you hear me? Can you hear my voice? Good afternoon. So, this is Junichiro Horikawa, and this is the weekly Houdini live stream, which is called as Houdini Algorithmic Live, to do some tutorial live stream using Houdini for a bunch of algorithmic design themes. And today I am going to try to create a process to convert a given 3D geometry into a ASCII art, so-called ASCII art, which is a art made by all the letters by picking up the features from the 3D geometry. Now, most of the time when you create an ASCII art and computer graphics, you just use a contrast from a 2D image. But since we are using 3D geometry in this examples, rather than just using the contrast information or brightness information, I'm going to add additional features to try to visualize the geometry using letters, such as like curvatures or tangent field or something like that, which you could retrieve from the 3D geometry to make it a bit more interesting than the ordinary ASCII art conversion. Okay, so that's what I would like to try to do. Right, from scratch. So let's see how we could do this. If you have any questions during the live, please ask. Or if any feedback, suggestions, anything is welcome. Okay, let's start from scratch. I'm going to create a geometry node to start with. And the first thing I would like to create is obviously the base geometry, which you want to convert it into an ASCII art. So let's do that by first of all just using some test geometry like big head, as always. Alright. So let's try to use this as it is. And first thing I would like to do is to apply some diffusion information to each points, meaning some shading informations which can be used as a contrast information or brightness informations in order to convert these points or convert these surfaces into an ASCII art based on those contrast. Okay. So to do that, first I'm going to remove all the material informations from this and try to create some shading information using a simple node from Houdini. So I'm going to use the attribute delete first to remove such as material or UV. Maybe I could keep the UV, but let's try to delete the material. Okay. Let's just delete the UV as well, which I don't think I need it. Okay. And probably I might want to have a bit more resolutions to this big head in order to make high res shading information. So let's just bring up subdivide node to subdivide the geometry a little bit, maybe 1 or 2, to make it a bit more high res, like this. Alright. Now, next thing I would like to do is to create a shading informations using maybe a pseudo or some fake lighting or something like that. And I found out that the easiest way to create a fake lighting stuff is to use a node called what was it called? Mask by ambient occlusion node, which is the first time I use, but this was pretty useful in order to create. This is to create a masking on top of the surface by creating an fake or virtual lighting, directional lighting, or ambient occlusions. In this case, I'm going to try to create an ambient occlusion as a mask. So let's see what it does. I'm gonna turn on this one to see how it affects the geometry. And then by using mask by ambient occlusion node, the toggle calculate ambient occlusion is checked as a default value, and there you can control how much ambient occlusion value you want to this geometry. The red part will be a value close to 1, the white part is where the value is close to 0, and you're going to get a attribute called mask on each point. Okay, hi everybody, thanks for coming. Okay, so Val Arts is asking, please explain the idea concept, please. Okay, so to briefly explain the concept, what I'm gonna do is to try to convert the given geometry into an ASCII art, meaning picking the letters like A, B, C, alphabetical values, or all the letters of your choices to draw a 2D graphics of this representation of this geometry. And in order to do that, what I'm going to do is to first of all create a brightness information on top of the geometry, in this case using ambient occlusions, so to create a virtual shadow, so meaning you'll get a value in between 0 to 1 in terms of the brightness. And based on those brightness, I'm going to choose which letter to use, which letter to represent that specific point. If the point is really dark, then you might want to use the letter with small density, like dot or comma or small lowercase I or something like that, which uses small space for one character. If you have a high density value, if the point you picked up is bright enough, then you might want to use the character which fills the space a lot more than dot or comma, something like M or Q at mark or something like that. So that's the basic rule to visualize those points with the letters. And additionally, I'm going to get additional features from the geometry, such as curvature, direction, like principal curvature directions, or tangent field, to use that directional value to pick the corresponding letters. Now, from the letters, you don't really have the directional informations from it, but you could try to assume its direction by using a bit more geometrical analysis on those letters, such as using trying to get eigenvectors to see the flow of that character geometry. So based on those flows and based on the curvature flow on top of the geometry, we could match the letters. So I'm going to try to use at least 2 features to pick the corresponding letters for each point on the surface, which is going to be projected on the 2D plane. So that's my plan. So let's do that. Okay, so the first thing what I was doing is to try to get a nice ambient occlusion parameters using by tweaking these parameters, but I'm not sure which one's good because it's right now it's white and red. It's a bit hard to see, so let's try to convert these value into a bit more shading friendly look by making from black to white. The darker area will be black, the bright area will be white. So I'm going to use a point wrangle. And let's check the geometry spreadsheet. So we have this mask information which is from 0 to 1. So let's use this to visualize the geometry with a shading. So what I'm just going to do is to just color these each point with a mask attribute, and that's pretty much it. And there you go, you are going to get a nice ambient occlusion shading here. Based on this visual, maybe I can tweak a parameter a little bit more. Let's just to have a bit more contrast on the geometry. Like that. Okay. Looks okay, I guess. Alright. Not bad. Okay, so let's try to go with this for now. Thank you everybody for all your comments. Right? So I'm gonna name this mask transfer, and I'm going to also copy this mask, rename this mask to something else, or maybe I can just use mask as it is, maybe. Yeah, maybe. Okay. Well, so one thing I could try in order to make, probably I might want to have these darker areas to be a bit more darker, a bright area to be a bit more brighter. So in order to do that, I am going to try to modify the mask by using power functions to see how it works. Using power of 2, yeah, a little bit better. You have a bit more high contrast in between the dark areas and bright areas. Okay, sounds good. And let's go to the next step. Now, the next step I would like to do is to project this geometry onto a 2D plane. And in this case, I'm just going to use the orthogonal projections to make it easier. You could try to do the perspective projections by using the real camera, but that's going to take a bit of time. So I'm just going to project this geometry onto a 2D plane somehow to be able to create an ASCII art as a final visual. So to do that, first I'm going to create a 2D plane or 2D grid which covers the whole geometry, okay, in either direction, X, Y, or Z direction. Okay, so shall we do that? So in order to do that, what I'm gonna do is to first of all create a single size grid geometry. Like that, and make the rows and columns to 2 and 2 so that you don't have any inner lines, and make the size 1 and 1 so that you'll be able to, it'll be easier for you to scale it using vex. And let's make it placed on XY plane so that you can project it project the pig head on top of this face. Maybe XZ plane. No, YZ plane. Yeah, this will be better. Okay, now obviously the size is not big enough, so let's fit this plane with this pig head. What I'm gonna do, I'm going to use the point wrangle to modify the size by retrieving the informations from the original geometry, in this case a pig head. And resize, I'm gonna name this resize quad. Okay, first thing first, what I need is the boundary box information of this pig head. So first of all, I'll get a size information by using a function called getBox size, which you'll be able to get a size informations in vectors. And also let's get the center point position of the bounding box from the pig head, so that this will be the center point position of this plane. Okay. Now that I have this information, actually I want to make the grid as square, meaning the width and height is the same value. So I'm going to choose either width or height or X or Y or Z size of this pig head. Probably I'm gonna just use try to get the height information from this pig head. So in that case, the height is size.y. Okay, so this will be the size, the base size informations for this plane. But if the height is smaller than the X direction or Z direction size of this pig head, then the pig head will not fit on the plane, so I might need some offset value as an additional parameter, like that. Now I can just use this to be a size of the quad. In order to modify the size of this quad, you can just change the point position information by scaling the current point position. So currently we have square, and you have in total 4 points. And what you want to do is to move each point to a diagonal direction from the center with some vector value, so that the size will be h and h, right? In order to do that, currently you do know this size, right, for x and y. So the actual directional value for this value, you do know the vector direction. The vector direction is just a normalized p. Am I writing correct? Is this it? Forgot which one's the normalized. Okay. So you do know the direction, but you don't know how much you need to move on that direction. Okay. What's this A? So you can retrieve this A from the height informations by just using some simple trigonometry, or just use a triangular formula. So this is 2h, this is 2h, so 2h square plus 2h square root, and then you'll get a. So this is the calculations you'd need to do. So let's do that. So float a is equal to h divided by 2 power of or 2 meaning square of this value multiplied by 2 and then square root. Okay, now you can just create a directional vector which is a normalized p and then multiply by a, then you can move the point to that direction. And from the center, and you know which one's the center, this one here, so from the center move to that direction. There, okay, I think I'm missing something. And there you will get a square which can be used to fit this pig head. If it's equal to 0, it fits with the height, but as you can see, the height is not enough for the width, so I am adding some offset here. Okay, it's good. Okay, so this is good for everybody. Size function Houdini automatically recognize. Well, you can use get bbox size to use in Vex, and this is a prepared function for Houdini Vex, so yeah, you can use that. Hello everybody. When you used in Durango, I usually just use the match size node. Well, I realized there are node called match size as well, which could be much better in this case. I haven't used it myself, so I'm not sure how to use this. Require geometry to move and resize. Bounding box. So this should be it. Is it? I'm not sure. Scale to fit. Nice. Okay. This is much easier. I'm not sure how I can able to make it as a square. Maybe you don't have that option. This is cool. Well, I'm gonna remember this. Thank you. But I'm gonna go with this one for now. Okay. So where was I? So now that I have this grid which covers the pig head, and next thing I would like to do is to divide this grid or divide this square into some bunch of rows and columns so that I can use each cell as a placeholder for the letters. Okay, so to do that you might want to have a parameter how much divisions you want on x and y direction. Okay, so let's try to first of all let's try to have that parameter informations applied, maybe as a detail attribute. So I'm going to use the attribute wrangle to try to divide this grid using detail attribute. First of all, I'm going to set a parameter for an integer to say how many rows and columns you want. Maybe let's make this maximum like 300. Okay. And in order to divide the grid, the easiest way I could think of is to use a divide node. And inside the divide node, there is an option. First of all, turn off this convex polygon and turn on the breaker polygon here. And there you'll have an option to choose the size of the division here by choosing these values. Okay, by choosing these values. Okay, it's not changing somehow. Maybe X is not really doing anything, but I might need to change Z and Y. Oh yeah. So by changing these values, you can divide these grid with the size defined here. This is the size for the cell. And this is the size for this Z directional cell size. And this is for the Y direction. But you cannot just use like any random numbers here, because there is some problem in the top. As you can see, the size is not matching with other cells. So the best way to make the clean grid is to divide or get the height or the width informations from the square, and then divide with some numbers you have defined. Then use that divisional value created from value evaluated with that divisions to use it with this. Use it for these height or width informations, or divided size informations. So that's what I'm gonna do here. Try to estimate the value of each size of the cell by dividing the height, the total height, with this division. So in order to do that, you need to have a height or width informations from this grid. So I'm going to use the get bbox size function again. And since I have set the x and y the same size, I can just get either one of it, like size.x, then divide it by division. Then you'll be able to get the cell size. And I'm gonna apply this to a detail attribute so that I can retrieve it inside this divide node. Like that. Now going back to the divide node, I'm going to try to get that attribute from the detail by using detail function, get the own input, and the attribute name is cell size, and get the first value. Okay, I think I did something wrong here. Let's see. The cell size on the detail, okay, it says 0, so something is wrong. So probably I'm doing something wrong here. Let me check if I have got the size correct. Okay. First of all, I shouldn't use X, but I should use Z. Alright, now it works. Because X is this direction, it's equal to 0. So yeah, that was the reason. So it looks good. I can now go back to the divide node and just copy this parameter and paste it to here, since Z and Y shares the same size. Okay, now you get a divided grid in clean manner. Every grid cell has the same size, and by changing this parameter, you can control the resolution of this grid. Alright, let's go with 80. Okay, now the grid is ready. Now it's time to project the information of this 3D geometry on top of this grid. Now the first information I want to project is the brightness. Okay. So meaning I just want to transfer those black and white value, in this case control manage with the attribute called mask onto this grid in this direction, meaning in this case X direction. Okay, so let's do that. It's pretty easy. I can what I want to use is to project each information onto a cell as a primitive. So I'm going to use a primitive wrangle. Right, then try to get the informations from the masked geometry, which is this one, by connecting to the second input. And how do I call this? Projection. Okay, so in order to project or in order to get the projected informations for this geometry to this one, what I could think of is to do some intersection testing. So if this is the ball, or if this is the 3D geometry, and if this is the grid, I'm just going to cast a ray from each grid orthogonally, in this case X direction, and if it hits, then get the mask information. If it didn't hit, just apply something like negative or 0 as a mask information. Okay, so let's do that. But the thing is, currently the geometry and the grid is penetrated like that, so we need to have that as consideration. So in order to use the intersect functions in Vex, you first need to have a output information as a variable, something like intersected positions and UV. Now you can calculate the intersection calling intersect function, intersection test to the second input, which is this geometry, the pighead geometry. Then the starting position should be somewhere outside the pighead, so somewhere around here, or maybe here. Either way, probably better here. So that is the positional positive X direction from the current grid. So we need to move each grid position to the X positive direction. So the starting point of intersection, it will be P, which is the centroid of the primitive, plus some offset value in the X direction, which can be really big, just in case that the geometry could be really big. Or we could check the size of the geometry by getting the minimum and maximum of the pighead, and based on those values, maybe that's more safer. So get the maximum and minimum informations from the pighead. And what we want to do is to use the max.x, which will be the maximum X directional position. And just in case, I'm going to add some offset value to this. So this, I think this will be enough as a position. Now next you want to have an intersecting direction, the direction which you want to raycast, so which will be negative X. So in this case I could use a size of the pighead geometry to define how much I need to throw a raycast. So get the bounding box size from the pighead, the second input, then use size.x, and just in case add it by some additional offsetted value and to the negative direction. As an output, you get intersected position and UV. Alright, so if there is any intersection, the integer inter will be more than 0, equal or more than 0, meaning you're going to get the primitive numbers. So if inter is equal or more than 0, then you'll be able to get the mask information. So get the mask information by using prim_uv function from the second input. The attribute you want to get is the mask, inter is the primitive number, and uv to specify the position. Now once you get that value, you could try to visualize it by changing the color of each primitive to see if you have correctly projected. And seems not. Seems it's not working. Everything is white, meaning I think I have done something wrong here. Yeah. Let me see. Okay. First of all, I need to check if the intersection has success or not. So let me check. If intersection is equal or more than 0, then make it white. If not, make it black, and see if the intersection itself has success or not. Okay, not. So I think I did something wrong here. Alright. Let's see why. So this is the point position. Okay. And this is the... Let me try to change this to some random numbers like 1000 and 2000 and see if this is gonna work. Okay, it did work. So the things that I set using minimum maximum was obviously wrong, which I want to fix it. Okay, so let's see how I fix it. First thing first, using the maximum value retrieved from the pighead will be okay. Seems okay. Adding a little bit of offset, still okay, yeah. So seems like the one that I did here is some problem. The size value. Okay. Why? Size.x. Nope. Okay, I might need to multiply it by 2. No, didn't still work. Let me check what's the size here. What kind of attribute do I get? And also I'm going to try to get the max as well to compare. So the max is 0.9. Okay, the size is okay. Well, it looks okay to me. I mean, I'm just using the x coordinate of the size and to the negative direction. Shouldn't be wrong. Funny. So why it didn't really work? I'm not sure. If I multiply it by 2, 10. Okay, now it works. So probably the ray cast direction was not enough. Well, obviously I need to... Maybe this offset value was necessary. Yeah, probably like that. Okay, by doing that, the pros of doing like this is if I change the size of this peg head to something really big, it should still work. Yeah, like that. Now, the plane offset is a bit off, but that's fine. Okay, so now this seems to work. I can continue. Now, what I want to do here is to use the mask to color. Okay, so seems like I have successfully retrieved the mask information as well. So looks good. And let's also apply some primitive group to where it has intersected. So set prim group intersected to these primitive, because you might want to choose whether you want to apply a text to those empty spaces or not. You could do that, or you could remove the text to those empty spaces. So in order to do that, you might want to have this kind of information, whether this grid is intersected or not. Okay. All right. Now that I have a mask information, let's also apply the mask. Just copy the mask to the grid as is. And this can be used as the brightness information. Okay. So I could try to move the letters by using this brightness informations as an initial test. Then later I can add additional features from the geometry like curvatures to give a bit more optimized or detailed letter selection algorithm. So let's try to use this one for now to pick the letters. In order to do that, I'm going to use the font node to create a bunch of letters on Houdini as a geometry to create the surface, or to create the letters. Okay, just choose the font of your choice. Arial. Maybe I might want to use the bold font, so Arial bold. Okay. One thing you could do here, you could just type any letters you want to use like this, but it's gonna take a lot of time. So I'm going to list up all the Latin-based possible characters by using some Python code to get all the possible characters by translating the Unicode into characters. So what I mean by Unicode is, if you search for Unicode on Wikipedia, you could actually translate the Unicode value, which is these decimal value, to this corresponding characters like that. So that's what I would like to do here. Prepare a bunch of numbers, maybe starting from 33 until maybe 126, or you could add additional characters, and then convert it into letters using Python. Now this cannot be done in Vex, so that's the reason why I'm using Python. Okay, so since I'm using Houdini 19.5 as a version, the Python version is 3 dot something, so I have to write in Python 3 grammar. Okay, first thing first, let's create an empty string and then create a bunch of number arrays which will be used as a Unicode value. So from 33 to 126. So range from 33 to 126. Okay. And then for each numbers, I'm going to convert these I value, which is this decimal value, into a character by using a function called chr, which is to convert a decimal value into a text characters. And then add that character to the text one by one. Okay. I think I'm having an error. Where is that? Oops. Okay, looks good. Is it? Not sure. After I have created this string, I need to apply this to a Houdini attribute. Maybe in this case detail is fine. So let's do that. First I'm going to create a detail attribute by accessing to the geo node or geo information. Call the function called attriv. And the type of the attribute is global, which means detail. And I'm gonna name the attribute letters, then the default values empty. Or maybe I can just set the default as text. That will be fine. Oop, didn't work. For I, okay. I need in. Okay, now let's look at the detail. And I have, okay, it's empty, so didn't work. So I'm gonna make this empty. Then I'm going to call the function called set global attriv value. The attribute that I want to set is letters and apply text. Let's see. Okay, now as you can see, I have a bunch of letters converted from the integer to the letters. All the possible alphabetical characters, numbers, and some unique characters. Okay. Looks good. Now I want to access to this detail from this font node. So give a null node with easy to remember name. Connect with the Python. Let's name this letters. Okay, now it's time to get that information. In order to use the expression inside the font, first you need the back quote, and then call detail, the name of the node, the name of the attribute, and actually we want to get the string, so it should be detail s, and that should give you a list of characters like this. All right. Now what I want to do next is to calculate the density of each characters corresponding to a grid cell. And yeah, in order to do that, you need to separate each characters into a separate square. So in order to do that, I need to add additional text attribute to each primitive, and as a result, for each primitive you'll get a attribute like text index and text symbols, A text index is what I want. This is the number of each characters. If the character is separated into multiple primitive like this one, 1, 2, 3, you'll get the same text index, starting from 0, 0, 1, 2, 3, 4, and so on. Okay. Now that I have these, let's try to calculate the density. Now the density can be retrieved by just first of all set a base quad which will cover the letter, and then calculate the area between the base quad and the letter. So you can just divide the letter area with the base area, and then you'll get the density. If it's 100%, then the whole quad is being used. If it's 50, then 50% of the quad size is used as an area. Okay, so in order to do that, first thing first, we need to create a base grid for each letters. So in order to do that, I am first going to move this grid to organize this text a little bit. For example, move this letter a little bit to the upward by the center. Okay, so that the center of the font will now be at 0. Okay, now let's create the grid, the simple grid geometry. 2 by 2, 1 by 1, and I think we need to make this grid direction same as this pighead plane. So now that I think, I can just reuse this grid for this text. Okay, so let's connect this grid to a null node, name is grid, and then link to that grid using object merge. Like that. Make it yellow to know that this one, and it's being linked, then link to this grid. Now you can turn on the link network, which one is connected to which, by toggle this show for selected node, and by selecting to this grid you see which one's being related. This font is related to these letters and so on. Okay, now now that I have this grid, let's try to cover these font with this grid. Now direction is 90-degree different, so let's also rotate this by 90-degree. All right, okay. Now in this case, based on the height of this font, let's try to choose the size of this base quad. So just like I did for resizing the grid which covers the pighead, I'm going to resize this quad based on the text, but with a bit different information. Okay, and in this case I'm also retrieving the size Y from the second input. That's fine. Have an offset, that's fine. Everything else, this one is not really necessary. I think we don't really need to change the center, so just remove it, and instead we're just going to start from the own center, so like this. Or you can just say direction as it is. Okay, then you can change these offset to see, say, how much quad size you want, for how much base size you want for each letters. Okay, let's make it 0.1 for now. All right. Now that I have this grid, let's try to calculate the density for each letters at this point. So in order to calculate the density, I'm going to use the area. First of all, I'm going to calculate the area of this quad as a base, and do the same for each characters. And I want to pack the area for each text index. So instead of each primitive, I'm going to choose per piece and then use text index to pack the area, or get the total calculated area for each text index. Okay, and if I do like that, going to the primitive, oops, didn't really work. Is it? Did it? Per piece. Am I using the text index? Okay. If you have the same text index, you're supposed to have the same area, but not. Doesn't really look like so. So after all, you might need to just add it. Yeah, it's not really equal. This doesn't really work, does it? No, this is not just. Okay, so what's this for? Actually, not sure. Do I need to make this as a string? No, I don't think so. Refine to connect it. Okay, now it seems to work. I guess I needed to check off this thing here. But I need to check if this is really correct. If this area, this calculated area for text index 0, 1, or 2 is correct. Right now you have 0, the same area. I would like to make sure that this area is the total area of this text index equal to 0. So in order to check that, I'm going to just get the text index equal to 0. Okay, apostrophe. Recalculate the measure using a total area and compare it with, okay, so it says 0.084 and this one for each primitive 0.84. Okay, so it looks correct. Good. Now by having the total, the area of the grid, as well as the area for each characters, you'll be able to calculate the density by just dividing them. So use the primitive wrangle, calculate the density for each primitive. First of all, let's get the base area from the second input. And then calculate the density by dividing the current primitive area by the base area. this will be always in between 0 to 1, since the quad always will be bigger than the letters. And the density, let's check the density as an attribute. Okay, let's check. So you have round point from 0 to 3. Okay, so you don't really have much big density here. The maximum is like 34%. So in those cases, you might want to maybe remap these density into 0 to 1 for meaning normalize the value so that for ease of use. Okay, so that all the character has some possibility to be used. Okay, so let me go back to here and use the attribute promote to get the maximum value of this density from primitive to detail, get the maximum, get the maximum density, and then remap the density value using another primitive wrangle. Density is equal to fit density, which is in between 0 to detail to 0 to 1. Now hopefully the density will become from 0 to 1 like that. Okay, looks good. Now we are ready to actually place these text to those cell, each cell corresponding shading cell. Okay, to do that, I think it will be much faster to pack each text as a packed object. So let's do that. And in order to do that, I think we need to have a string piece information for each characters to use the option called name attribute. So let's have another primitive wrangle. I mean, you could just do this here, but I think it's better to make each process separately. So name. So the name just can be retrieved from the text index. You just need to make it as a string instead of integer. So the name is equal to I2A convert integer to string by calling the text index. And let's check primitive, and you have the name that looks equal, but actually these are string, these are integers, which we can't really see from the geometry spreadsheet. Okay, going to the pack, turn on name attribute to use the name to pack the corresponding names, and as a result, even if the primitive is being separated, you can have the one that shares the same name as one packed object. Alright. And I think we also want to transfer the area or density attribute to each packed object, which can be used to choose which one should be used for each shaded value. Alright. I think we have enough information to process the transferring. So what we need to do now is to the easiest way I could think of is to place each letters onto a corresponding cells is to use copy to points, right? And just in case, I'm going back to the pack and also transfer the text index as well as name. Okay. Now copy to point have a piece attribute option, which can be used to if the point and the geometry shares the same attribute, then you can just move that object to the corresponding point. So to do that, you need to create the points out of this cells with corresponding size information, right? So let's do that. I'm going to create a primitive wrangle. Hello everybody. So first let's create a point, which is pretty easy. You can just say at point at P. Now there are a bunch of informations you need to attach to each point. And one is the what text you want to use onto that point. Okay, as well as the scale of each cell. And also as an additional information, if you want to set the grid to where the intersection is false. So let's start from the intersection one. I'm going to create the integer value, which is use draw outside integer, which will be either 0 or 1. So I'm going to create the toggle parameter here. Use outside or draw outside. Like that. And then call that parameters. If draw outside value is equal to 0, then you don't want to draw these. So, or maybe you can just say if it's equal to 1, then just add the point. Spell mistake. And then you'll be able to choose whether you want to add the point. Okay, but I think I need to have additional conditions in order to check if the point is inside or not. So if it's draw outside, wait a minute, this is not really correct. If this is, I probably need to well, first of all, I need to check if the primitive is intersected or not. So intersected in prim group intersected prim num. Okay. So if this is equal to 1 and this is equal to 1, then you obviously want to draw, or draws outside, and maybe this is what I need. Okay, this will do the job. So you have two conditions: draw outside is equal to 1 or intersected. If the draw outside toggle is off, then the outside cells is not going to create the points, but the intersected one will. If it's checked, then all the cells is going to be used. All right. Now, next, I am going to find the best text characters based on the current mask information. Okay, so to find out the best matched value, you want to look for all the possible density from the packed information, which have all the density value, and what you want to do is to pick the closest text out of this list. Now, I am not sure if there are any efficient way to find out the closest value. Let me just check the Houdini vex function, and if there are no, well, there are functions like PC find, so maybe I can use those probably instead of using position as a search filter. So what I want to do is doing something close to new point, but instead of using point position, I want to use other attribute, in this case density. So probably I could use PC find, maybe, since this can change the PC channel instead of point position. Yeah. So let's try to use this, shall we? I'm gonna move this aside. This is a bit too big. Okay. And in order to use the PC find, I think I need to have these density as a point attribute. But right now I have it as a primitive attribute, those density and names. So let's promote that to point. Attribute promote. Density from primitive to point. Let's not delete the original. Now you will going to have a density on points. Maybe I could do the same for text index and text name and then text index. So text index and name, just in case. I'm not sure how I'm gonna use this. All right. Going back, let's search for the closest value using PC find. So PC find from the second input, the channel that I'm gonna use is density, and it might be possible that the density must be vector, but yeah, probably I might need to make it as a vector value. So after all, after I have promoted the point, I'm going to create a new vector value just using density as an x coordinate. So create the v density. Just set the density as an x coordinate to make it look like a vector. That sounds a bit hacky, but and I don't really know if it's gonna work, but let's see. You gotta try out. Now look for the V density, and the base search attribute that I'm gonna use is the mask, but use it mask as x coordinate, and the y and z will be 0, same as the density value. The radius, I don't know, it could be really big. And the number of points you want to search for, just 1. Yeah. Okay. Now, I only need to get 1, so if the length of the PTS is more than 0, then I could get the corresponding text point information, text point index here, hopefully. And let's see if I have got any by set point attriv to this PT. Maybe I can create the points if I have found any density value. Right? Right. Okay, and set point attriv, the name will be, I don't know, text PT. Okay, this should be 0. Alright, let's see. And right now I have primitive, so let's also remove primitive as well. Okay, so that I only have points, and for each point, okay, I have text point. Now everything is 62, so, or not, maybe I do have some random numbers, so it could be correct. 62 could be the one which has the lowest density to fit the black area. Shall we check? Try to get the 62 one. $62. So, looks like a comma, which obviously should be the lowest density of all the characters. So, it looks like it's working. Okay. It's getting good. Now I can set the name to each point with the name retrieved from this text point. So, name is inside a point attribute at txtpt, and set the name. Okay, let's see. So I got the names, and I also got the name here. Am I ready to use the copy 2 points, right? I haven't set the scale yet, but let's just check without scaling for now. And in order to move these to this one, I might want to move each packed object to the center. Yeah. So how do I do that? I can use the primitive wrangle, move it to the centroid position. Just set it to 0. Nope, didn't work. Primitive, nope. Doesn't it supposed to work for points? Okay, it did. Okay, so now it's being gathered on the center. Now I think I'm ready to, although I might not want to change the height position. So just keep the white here, just move the x and y. Alright, let's see. Now something is weird. Okay, I guess it's due to the direction. And what's happening here? Yeah, I guess due to the scale and direction, probably. I'm not sure. Is it? What if I do like this? Nope. Let me check by applying some scale, some random scale value. Like that. Still not. Kind of getting the point, which is funny. Okay, I think I was missing here. Name. Interesting. Well, the geometry has not been copied, but instead a point has been copied. Why is that? Why is that? Oh, wait a minute. It's the other way around. Shit. Yeah, this is the way it's supposed to be. Okay, well, it's a bit hard to see. Let's make the scale a little bit smaller. 0.1, 0.1, 0.1. Okay, so I start to see something here, and it looks like it is correspond to the text density somehow. Alright, so what we need to do now is to set the correct scale value, which can be retrieved from this grid here, and the corresponding, the current grid size. So we need to create the scale value by dividing this scale and this scale. So bring this to the second input. How do I name this? Copy to point info, or search for best letters. Okay, so let's get the size information from the third input, somewhere around here. Base size is, again, I'm gonna use the vector get bbox size. Okay, now let's also get the grid size from the current primitive, which is this one. Just get one of the primitive and calculate the size of that. But actually this size has been calculated somewhere before, which you have in detail, I think. This one, cell size. And hopefully this is still exist. So let's get that value, shall we? So do we have it? Yeah. So float cell size is equal to detail cell size. Now that we have to information, and from the base size I can just get the height information. Let's say base height. So now we can calculate the scale value, which could be a cell size divided by base height. And this SC will be used for all X and Y and Z scale. Or I can just say P scale in this case, because it's X1, Y, and Z should have the same scale. Like that. Alright, let's see. And now the scale has been correctly matched with the grid and looks already nice. Okay, and if I change the offset, you can make the text covering the grid, make it smaller or bigger, like that. Okay, so looks good and looks fast enough to operate, I hope. Let's try to check how fast this could be by rotating the base geometry. Which one? Yeah, this one. Animating this pig head with some simple rotation to see if it could work on real time. Something like that. Okay. So rotates 360 degrees based on those frame value. Like that. Okay, let's make it faster by making the frame a bit smaller. Alright, so let's see how this is going to be used. Okay, I guess the speed is good enough. Not so fast, but I guess it's fast enough. The searching part, maybe PC find was the good option, and maybe I can make this one, see if it's gonna speed up a little bit. Nope, doesn't really change, so I think it's fine. Okay, now you could try changing the density of the quad, I mean the resolution of the quad, something like that, really high. Still works. Okay, maybe that was too high. And you could still see the text if it close up. Now that's the ordinary ASCII art generation, just using the brightness, right? So what I want to do next is to try to use the additional information from the geometry for a text searching, the letter searching, such as curvature flow or something like that, to make it meaning more useful, makes it make sense, to make it sense to use it to do this kind of operation in three-dimensional editor or application, because what I have just done could be done in 2D after all. So the information you can get from 3D is something you cannot get from 2D images. So that's what I would like to try out. Alright, but so far it looks fine. And I guess what's good about this operation is that you could change what letter to use. You could just use a selection of letters of your choice using the font. Oops. For example, if you just want to use A, B, and C. Okay, something is wrong here. Okay, I need to turn on this text attribute. Still works even with the small number of letters A, B, and C, and you do see some pighead somehow. Interesting. It could also use characters which is not 1 byte characters. You could also use something like 2 byte characters, like Japanese. Shall I try that since I'm Japanese? Still works. Yeah. And if you don't want to show the outer areas which doesn't intersect with the geometry, you can go back here, toggle this off. You can trim the outside, just get the geometry side. Oh well, that's that. Now let's try to get some additional features. And before doing that, let me just try to organize this a little bit to go for the next step. And let me also look at the comment. Okay, sorry, I forgot to look at the comments. Thanks for all the comments. Is it possible to export the geometry as a vector for plotting CNC curve? Yeah, you could also do that. I have a streaming live video archive just for that, so try to search for that. The name is something related to plotter drawing for Houdini, plotter drawing with Houdini or something like that. If you search on YouTube, you could see that. Let's try to organize this. So this part is the geometry part, the projection, searching. Key. And this is the letter. And this is where you have calculated the density. And all sorts of attribute organization. Okay, now what I want to do, other than the brightness of the mesh, I would like to try to get additional information from this pighead somehow. So what could that be? Well, if you use something like measure node, you have a bunch of additional analytical values such as curvatures, gradient, and all sorts of stuff. Let's try with the curvature. And let's change this to principal, which you'll get a directional principal vector value. So let's try to use this directional value as an additional criteria to search for the letters. Sounds interesting. Smaller or larger, not sure which one's better. Let's go with the larger one. And if you look at each point, yeah, I want to apply this curvature to each point. So make it point. And you'll have a curvature vector value like this. I think it's this being normalized or not, maybe not. Maybe not. Oh, I think it's fine. Now, what I want to do is to use this vector to somehow pick the corresponding value which matches with the letters. Now, how do I do that? One thing I could think of, is to get some vector value out of each characters. Something like the directional value. For example, if you look at the dollar characters, dollar sign, maybe as a human we could assume that the direction could be like vertical. Sharp could be somewhere in this diagonal direction. Apostrophe, obviously vertical, and something like that. And how can we get that kind of directional informations? By not assuming by human, meaning doing geometrically. Now, I have learned some technique from the last 2 live stream that there is a function called SBD decomposition in Houdini, which you be able to get the eigenvector and eigenvalue out of the matrix. And by using that, you could kind of assume the direction of the whole geometry using this function. So I'm gonna try to get that way, shall we? Sounds hard, but it is a bit hard. Okay, so first thing first, I do already have the base curvature here. So what I want to do next is to project this curvature direction onto the grid, just like I did for a brightness. Okay, so to do that, I'm going to probably connect this here before rotating. Now, when you have projected the original geometry to the 2D plane, you'll be able to get the corresponding attribute somewhere around here. Just like you have get the mask information, you could also get the curvature information. So that part is pretty easy. And let's just apply this curvature as is to a curvature attribute. Let's see how it looks like. Okay, let's visualize it. Curvature, make it vector. Okay, so you do see a corresponding curvature direction plotted on the 2D, but I don't really need this x directional component or coordinate, so maybe I can make it 0. Since I have projected on a plane. So all has been projected, and you do see some kind of rules to those curvature value. You do see some kind of flow here. And I want to try to pick the character which have the same flow, same direction, to be mapped to these tiles. If it's vertical, I want to get the vertical characters like I or apostrophe, or no, this is not apostrophe. How do I call this? I forgot. Such as I or bracket or something like that. If it's horizontal direction, maybe I want to get this one. I want to get dash or something like that, or equal. So and together with the brightness, maybe you do have some rich selection. And maybe by controlling the weight, you can choose either you want to have more directional informations or more brightness information to be used as a criteria to search for the characters. Okay, so let's try to calculate that information from the characters. And where should we do that? Maybe right after the brightness. So this is the density. This is being normalized. Okay, so maybe somewhere around here. So let's think how we could do that. Now obviously we need to separate each primitive and calculate for each set of primitive based on the text index. Now going back to the vex functions, the one that I would like to try to use here is svd decomp, this one, in order to get the eigenvalue and the eigenvector value. The S will be the eigenvalue, U will be the eigenvector, or you could either use V as well. So in order to use this, you need the 3x3 matrix. And from the one that I did maybe on 104th episode, where I have implemented the paper called Developability of Triangle Meshes, I have also used this for a vector which has been transferred to 3x3 matrix by using an outer product, which is more like a cross vector, but in order to get the cross product, but in order to get the 3x3 matrix. Okay, so I'm gonna use this to create the 3x3 matrix out of vectors, and for here I'm gonna just put the same vectors for first input and second input, just as I did on the papers. So in order to do that, I need a bunch of point information for each primitive, so let's see how I can get that. First thing first, I don't really need those edge information. Then maybe I can resample each primitive as outline curve to get the point. So first I'm going to use the divide node. One thing I have to make sure that is to keep the text index attribute for each primitive. Let's check. Okay, I still have it. If I convert it into, if I use the resample node to retrieve a bunch of points, and more points you have, I guess more precise information you get. So let's make it 0.05 or something to make it enough points. Now I'm going to create a vector which will be from the center of the primitive, or center of maybe the centroid of the primitive to each point, and use that vector to calculate the matrix, add them all together, then use the SVD decomposition to retrieve the eigenvectors and eigenvalues. Okay, so shall we do that? And I think we have enough points. Let's try to use the point wrangle. to calculate the 3x3 matrix first by outer product. Okay, so first I would like to have each center point of the characters corresponding to those points. So in order to do that, you need to get the primitive ID or primitive text index corresponding to this point. So first get the primitive numbers from point prims and then get the text indexed from the primitive let's make sure we have this information. Check for each point. Do we have it? Yep, we have it. Now, we also want to get the center point for those primitive which shares the same text index attribute. So let's see how we could do that. Going back to the get bbox center. So we can specify the group, which groups to get the center from, right? So, I mean, actually what I want is not the center point of this bounding box, but instead the centroid, which is based on the area, but it's might gonna take some time to get that, or do we? Is there any functions to get the centroid? Nope. So I am gonna just try to use the bounding box center for now, but if it didn't really work well, then I'm gonna try thinking about getting the centroid based on the weights. Okay, so center, get bounding box center from the first input. The rule here is that the attribute text index shares the same value. Alright, now hopefully this will create the centroid of each characters. Let's check by temporarily create a point to that position. See if it works. So you do see added points here, so looks correct. It looks we do get the centroid or the center point of the bounding box for each characters. Okay, looks good. Now that I have the center point, we could calculate the direction by subtracting the point position with the center. And now we could get the outer product using outer product functions for direction and direction. Okay, now store this information to the attribute to check. Alright, so we have these information. Now what we want to do next is to add all these matrices for each primitive, then calculate the SBD decomposition. So to do that, what's the easiest way? Let me look at the attribute promote to see if we can add these points together based on the same shared text index or shared attributes or something. if we have that, we do need to have some piece attributes, which could be string or index. So let's store that information to a text or to a point. Hopefully this will work with the integer. Okay, now, so original class point to maybe primitive text index, and then in this case I want to calculate the sum, add all the values together, change the name to, what was the original name? Then the original name is mat. Change the name to sum mat. Okay, let's see if it did work. If it did work. So I have this sum mat. And for those truth primitive, it shares the same text index, so it should have the same matrix as a summation, and it does. So look, I hope this worked fine. Alright, now it's time to get the eigenvalues and eigenvectors out of these matrices. So use the primitive wrangle. And at this moment, I don't really need to calculate the SPD decomposition for each primitive, because some of the primitive shares the same text index. So maybe at this point I can just pack and calculate the SPD decomposition after being packed. Maybe that makes more sense in terms of the efficiency. Okay, so after being packed, I want to promote the sum mat, which doesn't really exist here. Okay, here we go. Okay, so for each primitive, now you have some mat transferred to a packed geometry, and now we can try to estimate the eigenvalues and eigenvectors. Okay, and okay, so here is the parameters, matrix 3, output, matrix, vector, matrix. Okay, so first let's create the output u and v. This is the eigenvalue. Now SVD decomp, and use the sum mat, then USV. Alright. Now out of these variables, you could either use U or V in terms of the direction, and you can use S as a scale. Now I think I just need the direction in this case, so let's try to use U to retrieve directional value. Now you can get 3 direction perpendicular to each other. So, and the first vector is always the largest if you use the SVD decomposition as a function, so which is pretty handy. So v1 is u dot xx. The first x is the row number, and the second x is the column from the matrix. And you are going to get, what you're going to get is the So this is U, and each column will be a vector, directional vector value, which looks like this. B1, B2, B3. And B1 always has the largest scale, B2 has the smallest scale, B3 has the B2 has the second largest, B3 is the smallest. And this will indicate the features of the matrix. For example, when you have created the vertices retrieved from the characters, you have picked all the points from the characters, and you have created the vectors from the center to each point, right? Like that. And you have converted this directional value to a matrix 3. And add all these values together and send it to a SBD decomposition. As a result, you get these three informations, which will in return will give you a 3-directional value. One is the most affecting direction with these matrix, and in this case A could be a vertical direction, then perpendicular to this direction could be on X direction, and the third direction could be the depth direction, which in this case the size could be 0 because this is the flat geometry. If it's 3D, you do have some size on the depth direction as well. Okay, so x-axis u dot yx u dot zx should be the vector we are looking for. Now let's try to visualize this. Since I'm on top of the primitive, I guess I want to set the vectors to points, but I guess it doesn't really matter. Okay, so let's check. Create another marker with B1. Okay, does it have it? Okay, well, it's not really shown. Maybe this doesn't. Okay, so looking at the direction, maybe let's make it a little bit smaller. For this explanation mark, vertical, as we assumed. This quotes, double quotes, horizontal, looks good. Sharp, diagonal, looks good. So everything, this is a bit irregular, but maybe probably makes sense in this direction. And each of the bracket, vertical, makes sense. These are a bit, could be random because it could be any direction. As you can see like this. It's pretty interesting, right? So maybe there are some like hierarchy where this could be really strong. This could be a bit weaker in terms of the directional choice. So in order to visualize that as well, you could use eigenvalue as well, which could be retrieved from the S. So multiplying by s dot x, which is the first value corresponds to v1, you could also visualize the scale of this vector. And now you could see this is really affecting, this direction is pretty affecting. This is a bit smaller. If you look at this one, this has less directional informations and so on. And this one is, well, this is pretty strong somehow. I guess there are a bunch of points to those zeros. That's the reason, maybe. Maybe we need to kind of control the number of points based on the position, probably. Yeah. To remove the biases. Maybe it's a bit too biased to these direction for this one. Yeah, we might need to fix that. But overall looks pretty nice, nicely distributed, and the direction looks pretty correct. Not so many horizontal direction. That's understandable. Okay. Anyway, looks fine. Alright, now let's see how we could use this then in order to search for the letters. Just bring it up here. And wait a moment. Actually, I don't really want to use the resample geometry, but instead I want to use the original geometry. So we need to kind of replace that somewhere. Right. Maybe after this we got the primitive. The number of primitive didn't really change, I think. No, it did change. Why? So maybe what I could do is let's see. Just copy this part. Connect it to the original geometry, and this should share the same number, 92 and 92, and just transfer the attributes that we need, in this case a sum mat. So attribute transfer the matrix. Yeah. And hopefully it will copy 1 to 1. Sometimes it does not, so it looks correct. Okay. Okay, now that I have two vector informations applied on each geometry, the projected geometry, and this packed information as vector 1, let's try to update the criteria, search criteria. Shall we? Right. So how do we do this? First of all, we need to, in order to actually in order to make this search available together with the density, I think it makes sense to convert the vector value into a scalar value, meaning one axisal value. So we could try to compare the curvature flow on a projection by calculating the dot product between this direction and the vector that we have calculated, and use that dot product as a searching criteria to see how it works. Shall we? So to do that, we could first of all get the, wait a minute, but this, in those cases, that doesn't really work in terms of this searching, which has done using the PC find. Right. So, in order to calculate the dot product for each one, you just need to for loop each one of the possible values. So that's gonna take a little bit of time to calculate. Let's see if there's any efficient way to do that, just like I did here using PC find. You could kind of try to use the same PC find with the vectors, probably, since this will accept vector value. But in those cases, I mean, even if the direction is in this way, I could also the direction could also be in the negative direction. So you cannot directly use this PC find as is with this one for these directions, because if it's negative, then you get the value will become smaller in terms of the distance. So let's make all the vector value, in this case a curvature value, positive, shall we? Going back to the projection, I'm gonna make the curvature everything positive. What do I mean by positive? What do I mean by positive? That's the question. Maybe all the x component of the curvature is positive. If the x component of the curvature is negative, then make it flipped. Maybe that could be the rule. Maybe that could be the rule. I mean the z component. So if curvature dot z is smaller than 0, then curvature multiplied by -1. Did it make sense? What about y? Yeah, maybe I'm gonna use with the y rule. So by doing this, every curvature flow is kind of a promise to go upward, either left or right, but it's always upward. So it will be more easier to evaluate or search for the best direction. Now do the same for the one that I created here. SVD decomposition. Where was this? Here. Now this one is kind of always upward somehow, but let's just make sure. No, not this one. This one? Yeah. So if v1.y is negative, then make it flipped. Just in case. There. Then update it. Now obviously some vector is too long, too big, and that might affect the distance calculation, so I want to make the maximum length of this vector to be maybe equal to 1 at least. Yeah. Or normalize. So maybe I'll try normalizing first. Even though I have multiply s, I'm gonna ignore that and just get the directional component. Now going back to the search, I can now try to create a new criteria here. First of all, the B mask, the vector based value for the density could be mask, mask, mask. And the curvature based value could be what was it? Curvature based value will be the normalized curvature. Yeah. The problem here is that the size, the maximum size of this mask and the maximum size of this curvature is not equal. Although, that's fine. Let's see how it works. Okay, now I'm going to add these values together as a criteria V mask plus V curve. Okay, and then look for the corresponding value, which is these value. Now to do that, you need to have the same equations to this packed informations somewhere around here. So let's do that. In this case, we have density, which is the density, as well as the eigenvector set, or you can just bring up the V1. And probably I need to promote this from primitive to points, because right now the point doesn't have that information. Only the primitive have V1, so we need to promote that. Okay, primitive to point. Okay, now that we have two vectors, we're just going to add them together. How do I name this? Just use the same name. Criteria density plus eigen V. Alright. Wait. This is for the point where it is, where did it go? Oh yeah, here it is. Okay, so I want to use this one to be used for the searching. Right. Hopefully this will work. And going back to this part here, I am going to now search for a criteria which matches with this value here. Okay, now as a result, let's show up the projection. Let's show up the outside as well. Now, I do see some differences. Right now, the outside, the area should be, the density should be 0, but it's choosing something different other than comma. Well, not sure why, but it did. That is because the direction of the empty space could be in any direction, so maybe I still do need to use a scaled value of the SPD decomposition, not just by normalizing, but if I remove this normalize, see what happens. Now it tries to use the less scaled text, but that's because this one is too big in terms of the scaled values. So if I divide by 10, and I kind of need to compare this direction of these text with the curvature and see how, if it's really affecting or not, right? For now, I'm gonna make it normalized. And in order to change the weight between the area and the curvature, I think I need to create some weight related value somewhere around here when you add these two values together. So let's do that, shall we? I'm gonna multiply this by density ratio, and multiply this by curvature ratio or flow ratio, and you gotta do the same things for this one. So copy this here, do the same where you have added those two values together. So multiply density ratio flow. I think that's what I thought, but let's see. What was the name? Flow. So by doing this, if you make this flow ratio 0, it's all based on the brightness. If you make density 0 and flow ratio to 1, then it's all based on the direction. Now, doesn't really look, the flow doesn't really look obvious, is it? Maybe it's not really correct. So let's try to visualize the flow. So you have some vertical direction here. So I would want to see some vertical related text applied somewhere around here. Do I see it? Maybe, but yeah, this one it does, this one it does, but not really so obvious. Not so obvious, is it? Maybe I do need to take an account with the S value here instead of normalizing. See how it changes. If I make it divided by 10 here. 5. Not really so obvious, is it? Make it 1. Now everything becomes really small. The direction looks correct, but not so really obvious. Interesting. Yeah, the brightness really is really necessary to make it realistic. And as additional information, I was hoping this flow ratio will do something better, but not so much. Maybe the way to create the criteria was not good enough, I think. I'm just gonna make it back to the normalized file. Going back to here. Now you do supposed to have some directional related criteria added to the. Now this is when you don't really have a directional like preferences, and when you add this one up to 1, you're going to add some ratio here, which will take in account these direction, the curvature direction. Maybe I want to change the direction to something else smaller. Yeah. So in this case, you have horizontal direction on the top of the ear. So let's see if we could see that by raising up the flow ratio. Kind of. I mean, W used to be horizontal direction, so kind of working, I guess. Making less area. Well, not so obvious. Maybe it might still be better you calculating the dot product in between the the two vectors instead of just searching with the PC find. Yeah, maybe I want to do it that way, because this doesn't really seem to work. Maybe just the brightness is fine, maybe not with the flow ratio. Right. Let me think if we can convert this into a flow value somehow at this point. The curvature. So the curvature is something that goes from bottom to top, and we can kind of make that as a flow value by calculating a dot product between z-axis, I guess. Z val, z dot in between dot 0, 0, 1 and v curve. So if it's going the right direction, you get positive value. If it's going to negative direction, you get, I mean, if it's going to the left direction, it's going negative. If it's going up direction, it's 0. Right? So that make more sense, I guess. And by doing this, you can just use the scalar value. So instead of making a mask as a vector value, let's make the criteria something like set mask and z dot 0. So you have a area based criteria on the x coordinate, the directional flow value on y coordinate as a criteria. That might make more sense. Yeah. And do the same for the the calculation on packed geometry, but before doing that, let's also multiply the ratio. What's the name? Density ratio. Well, let's see. What was it? Flow ratio. And probably I might not need to and like multiply these ratio to the packed geometry after all. Maybe that's not really necessary. If you make it same value, then you just get the same value. So probably I should not multiply these value in the packed geometry after all. Okay, going back, let's recreate the criteria. So the eigenvector is this one, but I want to calculate the z value, the z dot value between z axis and eigen v. Alright. And try to create the criteria pretty similar to what we have done. Eigen v. No. F density for x and z dot for y. That's it. And without multiplying any ratio value. Okay, so going back to here, let's check. So this, if the flow ratio is equal to 0, only the area searching is being used. Looks pretty correct. If I enable this flow ratio upward, it will also take account the direction, hopefully, and if I make this density 0, only the directional part will remain, and looks pretty much correct. This is horizontal direction, and if I change the curvature, principal curvature to larger, this will become vertical. So looks promising. This is much better in terms of the, yeah. As you can see, these points should be going vector upward, and it is choosing the vertical directional value here from the corresponding ratio, corresponding densities. And if I change this to smaller, let's try to use horizontal direction instead. So yeah, this criteria looks much better. Okay, nice. So I mean, as a result, maybe you don't really see much difference between just using the brightness or by adding flow value. but you do just wanted to show you are able to add additional features for searching to not just use the brightness, which is often used for the 2D images, but you can also take account the information from the geometry. You could also try to use a new component from 19.5, like a one called tangent field, which will create the clean tangent vector field from the geometry, which is pretty nice, like that. And you could try to use that as a guide information. In those cases, this is named as field, so I might need to rename it. To curvature, because I was using curvature as a name. Does this work? Okay, in those cases, how does it go? First of all, the curvature looks like this. Looks more cleaner than the principal curvature, but kind of a weird direction here. But anyway, let's see if it being used to search for the text. Maybe. I don't know. You do see some like diagonal direction somewhere around here. If you look at the projection, the curvature on, yeah, you do see some direction going this way. So I think it is taking account. So something like that. I mean, just by using flow direction doesn't really make sense in terms of the ASCII art. You can't really see what's happening here. But combining with the brightness, you could enrich the result by adding additional informations to the image, might be, which is not possible just by converting to the image. So that might be interesting as a process. I mean, this is just an idea. This could be transferred to something totally different, but just to, I don't know, seed you guys with some ideas that I myself think could be really interesting. Maybe not the result of this one, but maybe for some other usage could be interesting. Okay. So that's what I wanted to show for today. Hopefully you have enjoyed it. You have learned something new, and let me look at the comments again. Sorry for Thanks for all the comments, everybody. I really appreciate it. May I suggest that you make the characters be Junichiro? That will be interesting. Okay. Thank you. If I play it. I have a suggestion from Olive, something to quickly play the vector field. Sounds a good idea. Let's try that. I'm gonna fix the rotation for the peg for now. And try to animate the flow instead. Which maybe I could animate this tangent field flow, which is a bit slow to calculate, but let's see. There is a value which you can use to rotate here. Okay, and see how it affect result. This is interesting. Oh wow, I do see some changes here. Yep. So good to see that it is taking into account, at least in some way. Nice. Very nice. If I make the density ratio small, nice. I could see it. I could see some flows. Interesting. Yeah, this is obviously only possible in 3D geometry, for sure. Not really possible just from the 2D image. Okay. Thank you for the suggestion. This is really great. This is really great. I love it. Love it, love it. Okay. Yes. Try this in game will be really interesting for sure. Would be great. Composite it multiplied over a test trend. Yes. Well, I will upload the file to the GitHub as always, and you can download the file from the video description page of this YouTube archive. Yeah, I'm gonna paste the link to the YouTube later. I'm also going to upload the files to a Patreon page, so you can also download from there for free. So anybody who is interested, please try to check it out after I finish the live stream. Okay, that's pretty much it. Let me just organize all those parameters I have set to one node, and I will finish this live stream. Okay. Thanks to all the people commented. I think I've learned a new stuff during the live again. That's what's good about using live stream. Let's also test out different geometry like squab. Yeah, and it still works. Okay, good, cool. Thank you, Olive, for coming and all the feedback. Appreciate it. Have a good day. Okay, let's create a bunch of parameters, shall we? First of all, a shape to switch. Okay. Subdivide. Well, this could be. It's not really important. The mask by ambient occlusion, yeah, this is not really important as well. I'll just leave it. This is also not necessary. Yeah, this offset value could be parameterized. Base quad offset. Base quad offset. Even in animating the amplitude of the color value, you could phase in geos so much. Nice. Yeah, that will be a nice idea. Okay, divide. This is also. You could also animate this divisions as well, you know. That, just like from the Super Nintendo effects. Quad div, quad div. Tangent field. Maybe you might want to switch between the flow, in between curvature and tangent field, or something different. Maybe you could add that flow by yourself later. What else? Projection. No parameters. Okay, this is obviously important. Density ratio, flow ratio. Font. Resize quad. Yeah, this is also important. This is for the text base offset. What else? Density, normalized density, matrix. I could just leave these as is. We don't really need those parameters. And that's pretty much it, I guess. Okay. So we have all the parameters. Let's connect this to a null node as a final output. And let's check that we can change a bunch of changing flows, text-based, size, density ratio, flow ratio, shape. Yeah, that's pretty much it. Okay, well, thank you very much for joining the live stream. As always, I'm really appreciate it. Toggle for sampling color of the model texture would be good to add later. Yeah, that would be another great features. Maybe without removing the material, sampling the colors, and use that information to use for other criterias, RGB. Yeah, there are so many options you could do with this. Just gonna end with this, but please try to extend with your ideas. Changing the grid divisions. My last one now, divisions animated on a visual curve, then transform merged into an input Uno to duplicate the grid across creating geo and the font. Then that's all. That's also interesting. Yeah. good one. It's a good one. I don't really have time right now to do that, but that's really promising, I think. I think I would like to try that later. Transform, change, merged into duplicated. Yeah, that would be nice. Thanks for all the feedback. Everything is great. Now I think I would love to end the live stream at this point. I guess there are still a bunch of things you could do, as everybody is suggesting, like Olive. But hopefully it satisfied your interest. Okay, so that's it for tonight. Thank you very much for joining me. I would like to do another one on next week with some different topic. Yep. As always, as I said, I'm going to upload the files to the GitHub. You could download it from the video description page from YouTube or Patreon. So if you're interested, please try to download and play it out with yourself. Okay, that's it. So good night and have a good day. It's almost 2 a.m. in Japan time, so I think it's time for me to go for a sleep or to another work. Yeah. All right. Good night all. おやすみなさい。